All right, sorry to have done that to you, but this is the second part of the lesson 4 conditional probability video. So it says a student selects a playing card at random from the following 6 cards. So they have a 9 of hearts, 5 of spades, 6 of hearts, 2 of spades, 4 of hearts, and 7 of hearts. So it says let A be the event that Molly selects a spade, and B is the event that Molly chooses an odd number. So the probability of event A is the probability that she is selecting, make this bigger. I don't know why it's so small. So the probability that she selects event A is a spade. So how many spades are there? 1, 2 spades out of the 6 cards that we have. So this is a probability of 1/3. Probability of event B will be as odds. So how many odds do we have? 9, 5, and 7. So there's 3 odds out of the total 6 cards, so the probability of choosing an odd is 1/2. The probability of choosing a spade and an odd. Well, how many do we have that are spades and odd? Well, here's an odd spade, but this spade is even. So there is only one that is spade and odd out of all 6. Down here, conditional probability says the probability of event A given event B has already occurred. So this is the probability of choosing a spade given that you've already chosen an odd. So what we're doing is we're limiting our sample space to include all of those that are odd. So how many are odd? 9, 5, and 7. So there are 3 that are odd. So how many of those odds, here's an odd, here's an odd, here's an odd. How many of those odds are spades? 1 out of 3 of them. This one is asking it a little bit backwards. It says, what's the probability of you selecting an odd given that you've already selected a spade? So now we're going to start by limiting all of this to the probability that we pick a spade. Let me get my eraser because I've kind of drawn all over this. So the probability of picking a spade is 2. So then it's asking for, of those spades, what's the probability of getting an odd? This one. There's a 1 in 2 chance then of getting a odd once you've already picked a spade. So now let's go through select all that apply. It says the probability of A given B. So the probability of A given B that we calculated was 1/3. Does it equal the probability that we calculated for A? Yes, it does. The probability of B given A, we calculated as 1/2. Does it equal the probability we calculated for probability of B? Yes, it does. Selecting that. Because these two things have been upheld, that means these events are independent. They have nothing to do with each other, which makes sense. If I'm drawing these cards randomly from the 6 cards, they don't have anything to influence, no influence on each other. Because I selected that the events are independent, they're not going to be dependent. That's the opposite. And let's check this last thing. The probability of A and B we calculated to be 1/6. Does it equal the probability of A, which we calculated as 1/3, times the probability of B? 1 times 1 is 1, 3 times 3 is 2. So yes. So if events are independent, then all 3 of these things will apply. Last piece. All right, Andrea is a good student. Says the probability that she studies and passes her mathematics test is 17 out of 20. So what I'm going to do with this sentence right here is I'm going to turn it into probability notation. So it says the probability that she studies and passes her math test is, meaning equals, a 17 out of 20. So there's one sentence. Then it goes on to say, and let me get another color here, if the probability that Andrea studies is a 15 out of 16, let me use green. So the probability that she studies equals a 15 out of 16. It says, find the probability that Andrea passes her mathematics test given that she studied. So one more thing here. Find the probability that Andrea passes her mathematics test given that she studied. So what we're trying to find, the probability that she passes her mathematics test given that she studied. This is the big if right here. So I have all of this laid out. What I'm going to do next is going to just label some things for a minute. What if I call the studying event A and passing event B? So if studying is A, I'm going to label this as A. So if studying is A, passing is B. The reason why I'm doing that is because if you look back to your notes, it says that the probability of B given the probability of A is equal to the probability of A and B all over the probability of A. This here limits our sample space. So if I want to find the probability that she passes given that she studied, I need the probability that she studies and passes. Well, that was given to me as 17 over 20. Then there's this big fraction bar right here. So better yet, maybe I can color coordinate this a little bit better. So the probability that she passes and studied is this 17 over 20. And I got that from that yellow highlighting right there in the word problem. Then I need to divide it by the probability of event A, which I have labeled as studying. So I'm going to divide it by 15 over 16. Grab your calculator and divide these events. So on the calculator, 17 divided by 20 divided by 15 over 16, I ended up with a fraction of, where'd it go? 68 over 75. So the probability that she passes, given that she studied, is a 68 over 75, which is, I know we don't very often make it a percent, but it's a 90 and 6 repeating. So she has about a 91% chance to pass given that she studies. And that concludes lesson 4. Please let me know what questions you have. And again, sorry for there being 2 videos. Thanks so much.